Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a homemade, kind of interesting, I think, problem. We have e to the power I equals a plus bi, and we're going to be finding the value of a squared plus b squared, of course the numerical value. So what is e to the power I? That's such a weird number, right, with exponentiation twice. Well, apparently it is a complex number that can be written as a plus bi. That's what we're trying to find. So for this problem, we're going to be using Euler's formula, which is amazing, and we talked about it in the lecture videos. If you go ahead and want to check it out, I'll include some links. And let's get started. So I'm going to start with e to the power I, and I don't know which category this problem should be put in, like either a medium level or a hard level. Please let me know. I'll probably mark it as one of those. Anyway, so e to the power I is what? It's a irrational number and an imaginary exponent. So we're going to use Euler's identity, which is e to the power ix equals cosine x plus I sine x. So whenever you have something like e to the power ix, you can basically write it as a complex number in standard form. You can kind of talk about rotation, vectors, so on and so forth. There's a lot of good stories. Anyways, but here's the thing. How do you compare this to e to the power I? If you look at this very carefully, you'll notice that here there's no x, because x is 1. And of course, x is measured in radians, needless to say, right? So here in this case, we have x equals 1 radians. So what is that supposed to mean? It means e to the power I is cosine of 1 radians, plus I sine of 1. Awesome. Great. We got e to the I, but how are we going to find e to the power I? Easy. We're just going to use this as an exponent. Since this is our new exponent, we have now e to the power I. So it's going to look like this. e to the power I, which is cosine of 1 plus I sine of 1. There's obviously a lot of good formulas for these kinds of identities, like what is e to the power z, when z is a complex number, but I'm just going to do it this way. So now notice that the exponents are added, which indicates we can separate it. We can split it into two pieces, like e to the power cosine of 1 times e to the power I sine of 1. What does this tell you? This tells you, hopefully, that this is the real part, or actually not the real part, I shouldn't say that. That is the modulus. Notice that? And this is going to be our number. When you take out the modulus, it's going to be e to the power I theta. So we basically wrote our number as r times e to the I theta, where theta is sine of an angle, which is kind of weird, right? So what does that mean? Since this can be written as r times cosine theta plus I sine theta, as we did here, right? Because r was 1, notice that. Now, r is not 1. r is e to the power cosine 1. So we're going to write it as follows. E to the power cosine of 1 times e to the power I sine 1 can be written as this. Cosine theta, and theta is what? Sine 1. This is the theta. Notice that. Cosine of sine 1 plus I times sine of sine 1. Sine 1 is a value, and we're signing it again, and then we're cosining it again. Okay, great. So what is this? This is e to the power I. e to the power I. And we're supposed to write it as a plus bi, right? Remember, the given problem told us, okay, we're supposed to do this. So how do you write this as a plus bi? We can go ahead and distribute. Exactly. So this can be written as e to the power cosine of 1 times cosine of sine of 1 plus I times e to the power cosine of 1 times sine of 1. A lot of ones, right? But they're all in radians. And this is e to the power I. So we'll be able to write this as a plus bi. Yes, this is the a, and wait a minute, did I write b? This is the a, and this is the b. A plus ib, a plus bi, same thing. So what are we supposed to do? Let's go ahead and write what a and b are. E to the power cosine 1 times cosine, I don't think we need parentheses there. E to the power cosine 1 times cosine of sine 1. And then b is e to the power cosine 1 again. Notice they have a common factor times sine of sine 1. Again, you can formulate it. Now we're supposed to find a squared plus b squared. Fun. Okay, how do you do that? You square each expression and add. Let's do it. A squared is going to be from here, e to the power cosine 1 squared, but you can write it as e to the power 2 cosine 1. That's what happens when you square something. But when you square cosine, it's just going to be cosine squared sine 1. Make sense? Okay. And if you wanted to put the 1 around the parentheses, I guess you could do that. Sometimes I forget. And now, this is a squared. What about b squared? Same thing pretty much, except you're going to have a sine squared, e to the 2 cosine 1 times sine squared of sine 1. Awesome, we're almost there. Bear with me. Now, this is a common factor, so we can go ahead and pull it out. E to the power 2 cosine of 1 multiplied by cosine squared sine 1 plus sine squared sine 1. But remember, this was our new theta, and you have cosine squared, let's call it alpha if you want. I mean, it doesn't matter. But sine squared alpha, I don't know, I'm writing different things. So sine squared alpha plus cosine squared alpha is going to be 1 all the time. Remember that, we used it once. And the answer is going to be e to the power 2 cosine of 1. And that is a squared plus b squared. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.